Okay, welcome back, ladies and gentlemen. This particular video, we're going to focus our attention on bond valuation, specifically on questions 4, 5, and 6, and we'll actually pick up on question 7 again with regards to equity valuation as well. So, first question, having to deal with Bovee International bonds, having an annual coupon rate of 10% and a par value of 1,000 that mature in 20 years. If we require, our market requires an 8% return, what price would we be willing to pay for the bond? So as we learned in the chapter content, basically all we have to do is a present value calculation in this case, okay? And in this case, I'm putting a negative sign in here. You don't have to do that. I just do that to make it look pretty. It'll just come out as a negative value otherwise, but that's okay. Either way, in this case though, in order to get the valuation we need a present value. We have our 8% rate, okay, which is right here in the problem. We have a number of periods, that's 20, okay. It says it's going to mature in 20 years. We have a payment, okay, that's our coupon, 10% of 1,000, so that is our $100 or 10% of 1,000, and our future value, which of course is our par value as given in the problem. Okay, we're not messing around with the type function here, so we put in our last parentheses, hit enter, and we end up with a valuation of $1,196.36. In effect, the price I would be willing to pay for that bond given current market conditions. Okay, quick and easy. Problem 5, another bond maturing in 10 years pays 10% interest on a $1,000 face value. However, interest is paid semi-annually. If my required rate of return is 12%, what's the value of the bond? And what is the value if the interests were paid on an annual basis? So our first question has to do with the semi-annual valuation, so we'll tackle that one first. Here, and go unhide our content. In this case, again, we have the same sort of present value calculation, but we have to adjust what we're doing for the fact that this is paying on a semi-annual basis. So first and foremost, we have to put in our rate. Notice we have to adjust it to 6%, okay? And again, in Excel, we can either put it in as 0.06 as we have it, or we could put in 6%. Both are fine. We have 20 periods. Notice this is 10 years, but because it's semi-annual, there's actually 20 periods involved, so that's why we have the 20. 50 is our payment in this case, because again, this 10% interest is paid on a semi-annual basis. So for the first 6 months of the year, I get $50. For the second 6 months of the year, I also get $50. So that's our payment. Future value, however, stays the same as it always is. Our future value is $1,000, and hit enter. And here again, we end up with our valuation. In this case, $885.30 is what I'd be willing to pay for the bond, because if we think about it logically, in this case, we have a 10%. Even though it's paying semi-annually, we have a 10% interest-bearing instrument, and the market is requiring 12%. Okay, so if I can go out as a new investor and I can basically buy a bond from another company and get a 12% return, if I want to buy your bond, in order for to attract me to buy it, you have to offer it as a discount. Okay, in order to compensate me basically for that difference in between 12% and 10%. Okay. Now, if I were to do this on an annualized basis, okay, very similar to what we've done before, except just like we did in problem 4, everything now is back to the way it was when we did the problem 4 calculation. Here we have 12%. Here we have the 10-year time frame. Okay. Here we have the $100 coupon value, okay, or the interest payment, and the $1,000 future value. Again, hit enter, and we end up with, as you can see, a slightly higher valuation or slightly higher cost than when we did under a semi-annual basis. Okay. So third problem here, McDonald's has bonds that are selling in the market for $1,100. These 20-year bonds pay 8% annually on a $1,000 par value. If the bond is purchased at market price, what is the expected rate of return? Okay, or this is another way of framing this is yield to maturity. So what we've got here, again, just as we learned in the chapter content, just as we learned in the chapter content, in this case we want to use the rate function. And in doing so, we've got a 20-year bond paying annually. So here's my 20. This is my payment, which of course is 8% on a $1,000 par value. It's currently selling in the market for $1,100 on a $1,000 par value. And all the other ones here, okay, we don't have to really worry about. We can probably get away with not even having the guess. In fact, hit enter, and we end up with 7.0522%. Okay. Now, if we were to change this to a semi-annual, okay, what would we have to do? Well, if this is a semi-annual bond, in this case, the number of periods then would be not 20, it'd be 40. Okay, payment would be, instead of 80, right, on 8% on a $1,000 par value, again, that would also be 40. Present value would be exactly as what we've seen before, $1,100. And the future value also as it was before, $1,000. Let's see if we can get away with not putting anything in the back end of that cell, which, as I mentioned, you don't have to do in a lot of your more current versions of Excel. So in this case, I find a 3.5296. Okay, so seems like there's quite a difference here between the rate function on the annual versus the semi-annual. But don't forget, this is only the semi-annual period. Okay, we actually have to double this in order to find the annualized rate. So we'll take this and just multiply it by 2. And here, now we can see that we've got, oh, we don't want to leave that as 7%. We're going to move that over as such. And we see that on a semi-annual bond, we don't earn a ton more, okay? But there is quite, basically we're, at the tenths, hundredths, thousandths place, we do have some difference, okay? And when you're talking $1 million or $1 billion, that difference can be pretty substantial. Okay, so that's it for our yield to maturity, or our expected rate of return calculation for problem 6. Okay, last but not least, looking at the equity problem. That's problem 7. Where we're evaluating the feasibility of building a new men's shopping oasis. This is a idea that came to mind as I was, walking around the mall with my wife some time ago, and basically, hopefully, would get me out of the role of carrying around bags while my wife and daughter shopped. Okay. Now, not unlike some of the problem that we've seen before, here we're again applying the capital asset pricing model. Okay, with some of the inputs given here. Companies analysts estimate a market beta for the project of 1.8 because this is such a crazy idea, where our actual market beta for a company's average project is 0.75. Financial forecasts for the new project indicate an expected rate of return on the equity portion of the investment of 20%. If the risk-free rate is 3.2, required rate of return on the market is 12. Is the new project in the best interest of Beauvais shareholders? Okay, so what we basically, to restate what we're talking about, okay, I need to see if we are actually going to, do better, okay, then, or basically compare my expected rate of return of 20% versus my required rate of return, okay? So in this case, again, I'm using my CAPM model, okay, to come up with basically my required rate of return on equity, okay? So for this particular type of project, this particular company, we're actually looking at our risk-free rate as we've done before. Here's basically my expected rate of return on the market minus the risk-free rate, and again, I'm multiplying it by the 1.8 beta for this particular project. With this in mind, I end up with a 19.04%, okay? And if I'm expecting to see new project and expected rate of return on the equity portion of the investment is 20%, that means that it's better than the 19.04% that is required on an investment of this type with this risk factor. Therefore, it looks like it's a project that we want to pursue, and we can press on. And with that, ladies and gentlemen, thanks for your attention, and we'll pick it up again with problem 8, which is a working capital management problem, and problem 9. Actually, we might do problems 9 and 10 first, and then come back to working capital management, just to keep things in sequence. So thanks so much, and we'll talk to you soon.